So let's say you're a tier one SOC analyst joining a new team at a new company, and you're not a Splunk expert, and you're trying to understand what sort of security data exists within your Splunk deployment. Using CSI, you might start with just a simple query like traffic. Here, CSI provides measurements around the data that's flowing into your Splunk deployment, specifically for the past 4 hours. Because we didn't specify a time range, it's going to pick a small enough time to return results fast. And we can see that the source types returned back show that we've got data contributing from Cisco SourceFire, Fortinet, Snort, even Palo Alto Networks, as well as semantic data sources. All of them are flowing in through a data model known as network traffic, and that's predominantly where CSI is pulling its data out to provide raw metrics, including total byte count, top 20 source, top 20 destinations, even network traffic by volume per hour, and then split out by source dest tuples per hour. So this is interesting, but let's take it one step further. Let's say that we want to refine this query and only focus on the traffic contributing by Palo Alto Networks data sources. So we can type pan traffic, and we can split that traffic out, let's say by source IP, source port, and app. Furthermore, let's not just look at the last 4 hours, but let's look at all traffic for yesterday. Now, very quickly, CSI will provide you with these corresponding measurements. You can see that it's actually including a date time range that includes for the past 24 hours, and it's filtered the data down to just the corresponding Palo Alto Networks traffic source type. It's still pulling the data from the network traffic's data model, and we can see that all of the corresponding metrics are now split by the fields that you specified here. CSI is able to return this data very quickly because it's using data model acceleration under the covers. This means that all of the data needs to be mapped to your common information data models and properly accelerated. We provide more details about how to do that in a free companion diagnostic app that we're happy to provide you called the CSI Readiness Console. For now, though, we can see that we've got useful metrics that show this corresponding time range, and CSI has provided additional visuals because we've now split the traffic out by these corresponding fields. CSI can do this and so much more. Let's focus instead on just pan traffic, but instead let's switch to traffic by location. Because we're including a geographical notation in the query, CSI knows that you're interested in source IP geomappings, and it presents this corresponding visual in the form of a geomap. Now, as the query is running, it's actually using the Splunk GeoIP mapping that's built in, although you can augment your Splunk deployment to include other GeoIP mappings, so long as it maps to IP location. Here, not only does CSI recognize the term location, but it's actually able to recognize cities, states, principalities, geographical regions of the world, such that if you wanted to drill into the data further, you could say, all right, let's say traffic from Germany yesterday. In this case, we've included a geographic location within the corresponding query, and you can see that CSI has actually pulled that out as part of the source scope. It includes the country code identifier and the full name of the country, but we can do the same thing with other geographic locations. And you can see that it actually updates the visuals based upon this location. It includes the top 20 sources, as well as the same types of panels of data that we had before, just refined now down to this corresponding query. We can do an even further investigation, though, by doing a comparison analysis of this data. So we can say traffic from Germany yesterday versus 3 days ago. Here, what we're doing is a comparative query looking at two different time ranges. In this case, we're comparing two different 24-hour periods, as denoted here. Using the same exact query that we've built, we can now compare total byte counts seen between these corresponding time ranges and cross-compare any top 20 sources seen between these corresponding time ranges. This helps investigators know what is normal in their environment versus what's abnormal. And there's so much more that you can do here, but this is just the start.